The first lesson for the second semester is Chapter 14, Introduction to Organic Chemistry. The learning intentions. In this chapter, you will learn how to define the term hydrocarbon and describe how alkenes are simple hydrocarbons with no functional group. They use the molecular or empirical formula of a compound given its structural, displayed, or skeletal formula. Interpret, name, and use the general, structural, displayed, and skeletal formulae of the alkanes, alkenes, halogenoalkanes, alcohols, including primary, secondary, and tertiary aldehydes, ketones, carboxylic acids, esters, amines, primary only, and nitriles. Explain and use the following terminology associated with organic reactions and their mechanism: functional group, homolytic and heterolytic fission, free radical initiation, propagation, termination. Nucleophile, electrophile, nucleophilic, electrophilic. Addition, substitution, elimination, hydrolysis, condensation. Oxidation and reduction. Explain and identify isomerisms, including chiral centers and geometrical. Deduce possible isomers from a given molecular formula. Describe, give bond angles, and explain the shape of molecules. Describe and explain the different types of structural isomerism and stereoisomerism. Formula. There are several types of formula. The first, molecular formula, for example, C3H6. This is the molecular formula for propene. The empirical formula is the ratio formula of propene. For example, here, the empirical formula is CH2 divided by 3. Structural formula for propene is CH3, CH, CH2 with double bond because the homologous series is alkene. And then you have the new here, skeletal formula. We don't have to write the symbol of atoms. We just draw the lines. Here, 3 carbon atoms, 1, 2, 3, with hydrogen here. And there is 1 double bond here. This is the double bond. So this is for propene. And then displayed formula, when we open all the hydrogen atoms, the term is displayed formula. Yeah. When we condense the structural formula, this is the condensed formula. Condensed formula. So structural formula can be displayed formula when we display all the hydrogen atom, or condensed formula when we gather the hydrogen in 1 carbon atom. For example, here CH3 and then only H and then CH2. That's the condensed formula. Here we have the question from your book related to empirical formula and molecular formula. On analysis, the hydrocarbon XI was found to contain 0.72 grams of carbon and 0.18 grams of hydrogen. Calculate the empirical formula of the hydrocarbon. Further investigation showed that the relative molecular mass of the hydrocarbon was 30. Deduce its molecular formula. So there are two questions here. The first is empirical formula. Empirical formula is the formula of the ratio of mole. So we have to find out the number of mole of the carbon and hydrogen in the hydrocarbon CXHY. So here you have 0.72 grams of carbon and 0.18 grams of hydrogen in hydrocarbon CXHY. Empirical formula is the ratio formula NC to NH. N is mole. Mole is mass over AR of C to mass over AR of H. That is 0.72 over 12 to 0.18 over 1. Then we get 0.06 to 0.18. The round number is 1, 2, 3. So the empirical formula is 1C and 3H. So the empirical formula is CH3. That is for number 1. For number 2, the molecular mass is MR. MR is 30. And then the empirical formula, this is simplified formula. CH3 has the sum of AR 1C 12 and then 3 hydrogen 3. So the sum of AR in empirical formula CH3 is 15. The molecular formula, until it is simplified, then the sum of AR is 15. So MR30 is CH3 simplified by factor n. 30 is 15 times n. So the n is 2. So the molecular formula is CH3 times 2, that is C2H6. Number B, a compound contains the elements carbon, hydrogen, and oxygen. Its empirical formula is CH2O and its relative molecular mass is 60. Deduce the molecular formula of the compound in the same way. The empirical formula is CH2O. Then you need to find out the sum of the AR is 12 plus H2 is 2 plus O is 16. So the sum is 30. This empirical formula is molecular formula simplified. And then the MR is 60. This is CH2O times N. So you get here 60 equals 30 times N. So you get N is 2. Then the molecular formula from empirical formula CH2O times 2. Then the molecular formula is C2H4O2. Number C, draw the displayed formula. We need to draw all the hydrogen atoms for ethene. C2H4, this is the molecular formula. Ethene is in group alkene. There is one double bond with 2C double bond. Then the valence electron or outer shell of carbon is 4. Here we use 2. Then the rest is 2. So you need to draw with 2 hydrogen for each carbon atoms. For propane, the group is alkane, all single bond with 3 carbon atoms, single bond. So here, the first carbon still has 3 hydrogen atoms. The second carbon still has 2 hydrogen atoms. And the third with 3 hydrogen atoms, all displayed. Open the hydrogen or draw the hydrogen atoms all. That's the displayed formula. Number D, draw the skeletal formula of pentane, a straight chain hydrocarbon with a molecular formula of C5H12. Number 2, draw the structural formulae of the molecules shown in figure 14.2, part D, E, and F. Okay. I want to answer number D1. Draw the skeletal formula of pentane. Straight chain hydrocarbon with 5C. This is the structural. Can display this is with H here. But the question is skeletal. So we need to draw 1, 1, 2, 3, 4, 5. That is pentane. 1C, 2C, 3C, 4C, 5C. Then we structures and naming. First, homologous series alkenes with double bond. General formula CnH2n. For example, ethene, CH2 double bond CH2. The second homologous series halogenoalkanes, RX, RaCnH2n plus 1, or alkyl. Here, for example, for alkenes, the alkyl methyl CH3, and then you have double bond. Here you have CH3. Here, for example, I change the R with ethyl, C2H5, and then you have here CH3. So what is the name of this? 1, 2, 3, 4, 5. This is the main change, that is pent. The double bond in position 1, 2. So pent-2-ene. That is the name for this. Then we have branch methyl or methyl. In number, carbon number, this is 1, this is carbon number 2, this is carbon number 3. So you have 2,3 dimethyl pent-2-ene. The second homologous series halogenoalkanes or RX, or R is CnH2n plus 1. So CnH2n plus 1 X, that's RX. For example, chloromethane. The CnH2n plus 1 is CH3 and the X is chlorine or Cl, CH3Cl. So the name derived from methane. 1H is substituted by Cl, so the name is chloromethane. Methane is CH4. One of the H is substituted by Cl, so you have CH3Cl. So the name is chloromethane. The third homologous series, here we have alcohols or alkanols. The structural formula in general is ROH. R is CnH2n plus 1. So alcohols or alkanols have the general formula CnH2n plus 1 OH or ROH. For example, methanol with 1C, that meth. The name is alkanol, so the name of CH3OH with 1C is methanol. When we have 2C, the formula is CH3CH2OH or C2H5OH, then the name is ethanol. The homologous series name is aldehydes or alkanals. The formula of aldehydes or alkanals is RCHO or CnH2n plus 1. This is R. And then CHO. Remember you mentioned RCHO, not RCOH. Yeah. Here the example is ethanol with 2C. So the formula is CH3CHO or CH3CH double bond O. That's ethanol. Or if we name with aldehydes, this is ethanol with alkanals, refers to alkanals. With the name aldehydes, the name is from the acid acetic acid, and the name is acetaldehyde for the ethanol. Yeah. Next homologous series, ketones or alkanon. The formula is RC double bond OR. The C double bond O is carbonyl group. For example, propanon. So prop is 3C. Then the carbonyl in between alkyl. So you have CCC carbonyl in between. So here you have CH3, then the name is propanon. When you name this with ketone, the name is dimethyl ketone. This is 2. Carboxylic acid RCOOH or CnH2n plus 1 COOH. Or we can write as RCOOH. For example, ethanoic acid with 2 carbon CH3COOH, or we can write the displayed formula CH3 and then C double bond OOH. The name is ethanoic acid. This is the name of carboxylic acid is alkanoic acid. The name with 2C is ethanoic acid. Refer to carboxylic acid. This is the trivial name. For alkanoic acid, this is IUPAC name. As carboxylic acid, ethanoic acid is acetic acid. Next, homologous series esters. The formula is RC single bond O and then C double bond O R. Or you can write esters as R C double bond O O R. For example, propyl ethanoate. CH3COO-C3H7 is propyl. CH3COO from ethanoic acid. So the name of CH3COO-C3H7 is propyl ethanoate. The next is amines R and H2. For example, methyl amine CH3 and H2. Nitriles R C triple bond N, or Cn H2N plus 1 Cn. We have here 2C, then the name is F. Ethane nitrile CH3Cn. Continue with the question. Draw the displayed formula of 2-methyl-butane. The main change butane alkane with 4 carbon atom. So the butane is C, and then you have methyl in number 2. 1, 2. Here you have CH3. The question is displayed, so you need to open all the hydrogen. Number 2, 3,5 diethyl heptane. Heptane is C7. So you need to draw 7 carbon. 1, 2, 3, 4, 5, 6, 7, and then in number 3 and 5, 1, 2, 3, you have ethyl. C2H5, this is number 4, number 5, ethyl. Yeah. And then you need to open all the hydrogen. And you need to open this with 2C, yeah. 2C. 1, 2. 1, 2. Like this. Then draw all the hydrogen like this. Yeah, continue. Yeah, finish this with all the hydrogen. The same for the number 3, 2, 4, and 6. 3-methyl octane. Octane is C8. The same way. Yeah. What is the name of this hydrocarbon? The main change, the longest change. 1, 2, 3, 4, 5, 6, 7. 7, yeah. 1, 2, 3, 4, 5, 6, 7. 7 is heptane. Heptane. Number 1 starting from left. This is methyl in number 3. 1, 2, 3 in number 3. 1, 2, 3. So methyl in number 3, and then ethyl in number 3 as well. This is ethyl. And we need to write the brands at methyl and ethyl. Alphabetical, so we start with ethyl in number 3. So the name is 3-ethyl, 3-methyl heptane. Give the skeletal formula of the hydrocarbon. Okay, what is that? What is 7? Yeah. What is 1, 2, 3, 4, 5, 6, 7, and then in number 3 you have 1 here, and then you have F5, 1, 2, so like this. Homolytic fission is unevenly bond breaking. For example, here you have HCl. The bond here, one is from hydrogen, this one from chlorine, chlorine in group 17. So the valence electron is 7, this one, the round one. In homolytic fission, the bond electron, the bond pair split evenly. So hydrogen get 1 and chlorine get 1. That homolytic fission. Heterolytic fission is an uneven breaking of a covalent bond. Here for HCl, H is more electropositive, Cl is more electronegative. In heterolytic fission, the bond pair is taken by the more electronegative atom Cl. So here hydrogen will split without electron that become H plus, and Cl get 1 electron then become Cl minus. The process here for HCl, the bond pair taken by Cl here in arrow, then the H become H plus, hydrogen ion, and Cl with 1 more electron become Cl minus. The heterolytic fission of a bond can involve a CX bond, where X is an atom more electronegative than carbon. For example, the other example here is bromomethane or methyl bromide, CH3Br. Bromine is more electronegative than carbon. So the bond pair between carbon and bromine will be taken by bromine, this one. So the CH3 become CH3 plus and Br become Br minus because there is 1 more electron. Nucleophile and electrophile. Nucleophile, species that can act as a donor of a pair of electrons. Remember, electrons minus can donor electron. Nucleo, remember nucleon. Nucleon or nucleus. Nucleus is positive. So nucleophile, species that like a positive part of the carbon chain. Electrophile, species in organic chemistry that can act as an electron pair acceptor or something that like electron. Electron is minus. So this is something positive. Electrophile is something positive. Nucleophile something negative. Or can donor pair of electron. Types of organic reactions. 1, oxidation. For example, oxidation of Ethanol produce acetic acid or ethanoic acid. Number 2, elimination. For example, ethanol in elimination produce ethene or ethene, CH2, CH2. Number 3, addition. For example, ethene, CH2, CH2 plus H2 to form CH3, CH3 or ethane. Number 4, substitution. CH4 with chlorine, one of the hydrogen will be substituted with Cl to form CH3Cl plus HCl.